to another CrosseMaths lesson. Okay, today we're going to go over indices. Now the advanced stuff, the negative rules and the fraction rules never really get talked about, so we're going to try and go through those today. What I'd like you to do is pause the video now and have a go at the starter in front of you. Okay, it's worth about, on a past paper, about 30 marks this is, so it's worth a big chunk. Okay, and these are topics that are easy to get right each time. Pause it now and have a go. Right then, so very quickly guys, I'm going to try and go through all of that for you. Okay, so what I'd like you to do, pause the video after each one if you want to mark it, okay? Or pause it at the end and I'll put all the answers up on one go. So we've got, okay, I'm just going to change my pen. Right, so we've got x squared take away 5x plus 6. Okay, we're going to factorise this in the double bracket first. Okay, you need to find numbers that multiply to make positive 6 and add to make negative 5. Numbers that multiply to make positive 6, you've got x minus 3 and x minus 2. 3 times 2 makes 6 and 3 add 2 makes 5. It has to be negative 3 and negative 2 to make negative 5, and 2 minuses will make a plus with the 6. Okay, those two brackets cancel out to make nothing. So the bracket on the left, x would have to be 3 to cancel it out to make nothing. The bracket on the right, x would have to be positive 2 to cancel out to make nothing. And those are your two solutions for x. First one done. Calculate a bit of standard form. Okay, 3.1 times 4. Okay, the two front numbers, you multiply them as if they're normal numbers. Okay, 3.1 times 4 is 12.4. Then the bits with the powers, you add your powers together. So if I add those two together, it's going to be times 10 to the power of 9. Okay, 12.4, however, is not between 1 and 10. To be a standard form number, the number on the left has to be between 1 and 10. In order to do that, I'm going to put the decimal point over 1, and I'm going to add 1 onto my power. 1 mark. Okay, this is what we're doing today. Okay, so if you don't get it now, if you do get it now, it's brilliant, really, really good. Okay, if you don't get it now, you will understand by the end of the day. Okay, there's 3 rules going on by here. There's the negative rule, there's this 2, which still means squared on top of the fraction, and there's the bit on the bottom of the fraction, which means cube root. Okay, because it's a 3, it normally just means root. Because it's a 3, it means cube root. Now I'm going to do one at a time. I'm going to do the negative one first. The negative rule just means reciprocal, so instead of 125, the minus rule means 1 over 125. Still to the power of 2/3, all that's happened is the minus is gone now, because I've used it. Okay, the bit on top, I'm going to do the bit on the bottom first. I'm going to cube root it, only because it'll give me a much nicer number to deal with. Okay, if I cube root 125, I just end up with 5. So I got 1 over 5 squared. 5 squared just gives me 25. So my answer is 1 over 25 as a final answer. So 3 rules, you've got to use them one after the other. The easiest way to do it is to use the minus rule first, then use the bottom of the fraction, then use the top. Right, write 0.84 recurring as a fraction, okay? That is x equals 0.848484 going on all day, okay? That's what it looks like. Okay, we've got to get both recurring digits over the decimal point. What we have got, we've got both recurring digits next to the decimal point, which is what we want later on. So, if I want to get them both over the decimal point, I'm going to times by 100. You end up with 100x equals 84.848484. Now, what I wrote down on the first line, I'm just going to write underneath. X equals 0.84. And the same way I would if I was taking away using column subtraction, okay, I'll do exactly the same thing. I line up the decimal points. If you line up the decimal points, you can see that the 84 recurring bits are actually perfectly in line. Now, if you do exactly the same as you would with simultaneous equations and you take them away, these bits cancel out. Okay, 84 take away 0 is just 84. 100x take away x is just 99x. You've got solving equations now. Take the 99 over the other side to change to a divide. So x will equal 84 over 99. And that's your final fraction. Okay, and the next one, I'm going to go to the right hand side now. I've got 8 plus 4 root 7. 5 take away 5 root 7. Okay, this is just FOIL. 8 times 5 is 40. Outside edges, 8 times 5 root 7. 8 times 5 is negative. You times the front numbers if they're normal numbers. 8 times 5 is 40. Root 7 just goes on the end. Inside edges, 4 root 7 times 5, 5 and the 4 times each other, gives you positive 20 root 7. And then the last one is where it gets a little bit confusing. Okay, the last is these two times together. 4 times 5 is 20. Root 7 times root 7 just makes positive 7. Then 20 times by 7 is what you want. Okay, so we're going to have negative 140. Okay, now the bits that will go together, the 40 and the negative 140 will go together. If you put those two together, it'll make minus 100. And then the minus 40 root 7 and the plus 20 root 7 is the same as doing minus 40x plus 20x. Okay, it'll give you negative 20 root 7 if you simplify. Right guys, a bit of circle theorems. Okay, the important rule here, angle at the centre is double angle at edge. Okay, when you get the arrowhead shape, the angle at the centre is double the angle at the edge. If you want to find what x is, x just equals 48 times 2, so x equals 96 degrees. Really easy one. Okay, a little bit of trigonometry now. Make sure you've got a calculator handy. Okay, I label my sides. I've got O, H and A. Write down my SOHCAHTOA. Okay, I cross off A. Okay, I'm going to be using SO. Draw my SO triangle out. Okay, I want sin. So if I cover the S on my finger, my working out is O over H. O is 5, H is 9. And remember, because we're finding the angle, don't want that. Bear with me. iPad's just having a meltdown. Because I'm finding the angle, I know it's going to be sin to the minus 1. Okay, so you've got to press shift on your calculator. Your higher teachers should know this anyway. You press shift sin, then 5 divided by 9 inside the bracket, close the bracket at the end. You should get 33.7 degrees for x. Right, last two, okay, higher tier starters do take a little bit longer. Okay, make x a subject, okay, we've got to get the x's on the same side. In order to do that, I'm going to expand the bracket first. X times a is just ax, x times b is just bx. D times x is just dx, d times c is just cd. Okay, I try to put them alphabetically if you can, it makes them easier to simplify. I'm going to put all the things with x in on one side, so the dx has got to come over, so I've got ax plus bx, take away dx because it's come over the other side, equals negative cd. I factorise this left hand side, so take x out as a common factor. If you take x out, you're just left with a plus b, take away d, is all equal to negative cd. And then I divide through by whatever's in the bracket. So I've got x equals minus cd, and everything that was in my bracket goes on the bottom. A plus b, take away d. Really, it's quite straightforward actually. These ones are really worth learning. Okay, they're the same pretty much every single time. Okay, it's really important you learn this topic as well if you're doing A-level maths. Okay, HCF and LCM are 42 and 360. Okay, so I've got to do prime factor trees for these two numbers. 360 breaks down into 36 and 10, which breaks down into 2 and 5. 36 breaks down into 6 and 6, 2 and 3, 2 and 3. Okay, and if you ever got a prime number, you've got to circle it. Okay, everyone will recognise this topic straight away. 42 breaks down into 6 and 7, and 6 breaks down into 2 and 3. Now, once you're there, okay, I've got to draw a Venn diagram for these two numbers. So I've done my two prime factor trees. That's easy, 42 and 360. Okay, if you look at the two sets of trees, okay, 42's tree and 360's tree, think about what numbers come up in both of them. Okay, the numbers that come in both of them, I can see a 2 in both, so I can put a 2 in the middle. I can see a 3 in both, so I'll put a 3 in the middle. I can't see any other numbers that come up in both lists. Okay, so my highest common factor is the middle bit times together. So my highest common factor, 360 and 42, is 2 times 3, which is 6. Right guys, hopefully you got all that done. That's worth about 30 marks in higher tier, okay, so a big chunk of it. Make sure that's marked. If you got anywhere around 15 or more, that is incredible, so well done. Right then, so a little bit of indices. Okay, these are just basic examples. Okay, everyone should know the rule that if you multiply, you add the powers, you divide, you subtract, and if there's brackets, you would times the powers, but we won't worry about that one for the moment. Okay, what I'd like you to do, if you really get this and you think you're on it, have a go at this yourself. Pause the video and have a go. If you don't, I'm just going to go through it. Right then, first one. The indices rules only apply with the powery bits. The 8 and the 5, I'm going to multiply them normally. 8 times 5 is 40. x2 and x5, because I'm multiplying, I add. So x2 and x5 simplify to x to the power of 7. So 40x to the power of 7. Next one, 4 times 7 is 28. Add the powers together. X minus 3 and x9, they add together to make x to the power of 6. Same thing on part C, but there's no numbers now, so I'm just going to deal with my powers. x4 and x6 makes x to the power of 10. y7 and y1 makes y to the power of 8. Same thing on D. Make sure you deal with the ones that it's the specific letters individually. A7 times A5 is A to the power of 12. B9 and B7 is B to the power of 16. Part E, okay, 5x all to the power of 2. Remember, you've got to square everything inside the bracket. So the 5, if you're going to square that, 5 squared is 25. X squared is just going to be x squared. Easy. Next one, square that. So square the 6 gives me 36. X to the power of 3, when there's a bracket and there's a 2 on the outside, it's the same as doing x3 times by x3, which would add together to make x to the power of 6. The quick way of thinking it with brackets is you multiply the two powers. Part G. Divide our two numbers. 20 divided by 4 gives me 5. If we're dividing with indices, we subtract. So x7 take away x3 gives me x to the power of 4. 9 divided by 3 is 6. X minus 2 take away another 5 is x to the power of negative. 9 divided by 3 is not 6. I don't know why I wrote that. Apologies. 9 divided by 3 is 3. X to the minus 2 and x to the 5. If you take them away, you end up x to the minus 7. 3x to the minus 7. 24 divided by 6 gives me 4. X11 and x3. If I take away those two, I get x to the power of 8. 42 divided by 7 is 6. A9 and A2 gives me a to the power of 7. B15 and B7 gives me a to the power of 8. Okay, b to the power of 8, sorry. So should be super straightforward. Pause the video now. I'd like you to write down every example you think you need. I think you'll need most of them, I'd imagine. Pause it and write them down. Right then, so what I'd like you to do, have a quick go with this. This is kind of intermediate stuff-ish. Okay, if the indices question turns up right at the start of the paper, you'll get a question like this. If it turns up in the second half in higher tier, you'll get a nastier question, which we'll go on to in a little bit. Right, hopefully you've had a chance to do those. Now, there's your answers, okay? So you can flick back and forth if you're not sure if you want to check the questions as well. Hopefully you wrote down what the questions are. Okay, if you mark what you've done, if you got one of the boxes correct, that's brill. Red is easy, amber is middle, and green is hard. Right then, so this is a GCSE question. So if it comes up in the first half of your paper, this is what it'll look like. Pause the video now and have a go, please. Okay, so this is a question that came out on higher tier calculator. I think it was question 1. So exactly the same as we did. 6 times 3, 6, the front number, 6 times 3 gives me 18. And then we add the powers together. P6 and P3 gives me P to the power of 9. 18p to the power of 9 is on the end. Next one, this was a calculator paper, so your two front numbers, now my 3.4 and my 13.6, I can divide them. Gives me 1 over 4. G8 and G2, if I take them away, is G to the power of 6. So I got G to the power of 6, it's 1 over 4, so it's G to the power of 6 all over 4. That's about it. Next one, M3 times M6 is M to the power of 9. It's still over m to the power of 9. If you take those two powers away, you end up with m to the power of 0. Anything to the power of 0 is always the number 1. Really straightforward question. Okay, if it does come up in the first half, it may come up in both. On one paper, it might come up in the first half. On the second paper, it might come up towards the end. Okay, so it is quite a big topic, and it can come up a lot. Okay, so mark those, make sure they're correct. Right then, so this is what you'll have, okay? You'll be dealing with questions like this, okay, fractional. Okay, it goes 16 to the power of half. Now the bit on the top doesn't really matter too much, the 1. This is the power, and this bottom bit is the root. So if it's a 2 on the bottom, it's a square root. If it's a 3, it's a cube root. They may go bigger than a 3. They may go to a 4. I'm not really sure. They might do. They could go to a 4, which would be quartic root case. Not really. We'll get to that in a little bit. So the power, if it's a 1, it doesn't matter at all. Okay, the power, not important. Okay, so if it's a 2 on the bottom, that means square root. So 16 to the power of a half is the same as saying square root of 16. Okay, square root of 16, 4 times 4 makes 16, so it's just 4. Exactly the same thing on the next one. 49 to the power of half is going to be square root of 49. Just gives me 7. 8 to the power of a third. That means cube root. 2 times 2 times 2 makes 8, so it's going to be 2. 81 to the power of a quarter. Okay, that means you're looking for a number that times is by itself 4 times to make 81. That will be 3. 3 times 3 times 3 times 3 makes 81. 27 to the power of 2 over 3. Now we've got a different number in the power section. So what we've got to do? Okay, we'll always do the root first. So I'm going to be doing cube root of 27. And then that power bit is still going to be there at the end. So cube root of 27 is 3. 3 squared just gives me 9. Okay, so you do one at a time. You do the root bit first, and then after that you do the power. Same thing on this one. It's going to be cube root of 8. And then once I've done that, once I've finished, I'm going to put it all to the power of 5. Cube root of 8 is 2. 2 to the power of 5. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay, now negative as well. Okay, it's going to be square root . Actually, what I'll do is I'll do the negative one first. The negative rule, okay, is 1 over, so this means reciprocal. All to the power of half. Sometimes it's easier to do the negative one first just to get out of the way, which would be the same as 1 over square root of 25, which is the same as 1 over 5. Quite straightforward, okay? Last one, again, exactly the same thing. I'm going to do the negative one first, which gives me 1 over 27 to the power of 4 over 3. Then I'm going to do the bottom bit, so the cube root. 1 over cube root 27, all to the power of 4. Cube root of 27 is 3. So 1 over 3, all to the power of 4. 3 times 3 times 3 times 3 gives me 1 over 81. Okay guys, worth pausing the video now and getting that copied down. Right then, so hopefully that's all down. What I'd like you to do as well, write these rules down. Now this bit and this bit is super important. The helpful hints make loads of sense. Okay, multiplication rule, you add the powers. Division rule, subtract the powers. Negative, write it as a fraction. Index of 0 is always the number 1, and power rule means multiply the powers. Okay, the power rule when there's brackets. Okay, so write those down. Pause the video now. That is the most important thing with indices. You've got that written down. Right then, so what I'd like you to do, some of them I've started you off. Okay, I'd like you to work through the questions in front of you. Okay, a bit of fraction indices. I've started you off on some of them. Pause the video now and have a go. Right then, cool. So I'm going to go to the first one. The first one they've started you off, it means square root of 25. So my answer is just the number 5. Okay, 36 to the power of a half means square root of 36. So my answer is just 6. So cube root of 27 is just 3. So my answer is 3. Some of them they've helped you and started you off with the working. Cube root of 4, sorry, is square root of 4, and then cubed is 2 times 2 times 2, which makes it 8. Cube root of 27 is 3. 3 squared gives you 9. And then the last one, which they haven't helped you with at all, cube root of 8, all to the power of 4. Cube root of 8 is 2. 2 to the power of 4. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. 16 is an answer. Okay, pause the video, mark those. If you got them right, that is awesome. If you didn't happen to get them right, don't worry, it's not the end of the world. Right guys, so we've got one final GCSE question just to finish us off. Pause the video now, have a go. If you get this right, you really understand this. If you don't get it right, don't worry, it's not the end of the world. You just need a little bit more practice. Right then, using the rules we've just done, okay, 1 over 36, I'm going to use the negative rule first, the minus rule. Okay, if it's minus, you've got to flip the fraction upside down. It would be 36 over 1, which is exactly the same as 36, all to the power of a half. 36 to the power of a half is same as doing square root of 36. Square root of 36